Adding extra manually designed sources can help you to art direct the simulation and sculpt it to your liking. So in our current version of the sim here, we're not seeing enough emission on the impact of his hand or his head. These are some pretty massive impacts happening when his hand first hits the building there, and when his head hits slightly sooner. So we want to emit some extra density there and pump in some extra velocity. And I also found that when his hand swings down at the very end, it would be nice to add some extra density and velocity there as well. This flipbook stops a little bit short of seeing that well, but it would be nice to highlight this influence of that hand swinging down. Now to keep this network clean, I'm going to create these extra sources in a subnet in the middle here. I'll just call that extra sources and then dive inside. Now inside this subnet, I'm going to start with some geometry sources that I've already created. And you can create these geometry sources however you want. You could place some spheres or hand sculpt things and make this as complex or simple as you'd like. For the case of his head impact, I've created this animated sphere and added some detail to that and created some subdivisions and some more detail and then converted that into VDBs. And I've placed that exactly where his head would be impacting the building. However, we don't want to create density inside his head. That could potentially cause some issues in the simulation. So I'm also creating a VDB from that monster and using a VDB combine with the method set to SDF difference so that we can chop out the monster region from this density source that we're creating. I should also point out that the reason I'm animating this source sphere is because I want that shape to expand a bit as the monster collides. So I picked 999 and 1000 as those extra source emission frames. And if you look at the geometry shape on those two frames, I've sculpted that in pretty nicely to create this nice little silhouette of density that will be added to our sim. And then if you step one frame forward, you can see that's spreading out a little bit wider so that as his head moves, it doesn't cover up that source as much, and we're getting a nice dense kind of moving cloud of emission for those two frames. And once we have this source shaped here, we can use the Pyro source SOP to create some initial points for that. So we'll connect our VDB combine to that Pyro source, and I'll set that mode to a volume scatter to fill that entire area. And right now, these points don't have any attributes associated with them. All they have is a p-scale attribute. So under the attributes option here, we can hit plus to add one. And if you select density from the drop-down, that will add a density point attribute for you. And our final simulation is going to be higher res than 0.1 for the voxel size. So I'm going to set this pretty small, like 0.03. And this might be a bit overkill because that's a super dense cloud of points there. But I just want to make sure that we're adding a detailed enough volume that this will be nicely reflected in the high-res version of our sim. And now that we have these source points, you can set a velocity attribute on that however you want. In this case, I'm using a point wrangle to set that in Vex. And then in that wrangle, I'm setting the velocity based on a reference point. Now this Vex starts by setting a v-origin local variable to the center of the bounding box, but then I'm setting the x portion of that vector to the minimum of the bounding box, which will put it to the back of this point cloud here, since we're looking down the x-axis now. And I'm also setting the y portion to the minimum point of the bounding box as well, which will put that point down at the bottom here. Now for the z-axis, which is our left to right axis from this view, I decided that I want that reference point to be somewhere in between the center and the minimum z bounds. So I'm using a lerp function to blend that z value about 70% between the center and the minimum. So that would be somewhere around here. And then with that origin point set, I'm then looking up the vector from each current point position to that reference point, and I'm normalizing that to get a velocity vector in this direction radiating outwards. And that normalized unit vector would be pretty small, so I'm also multiplying that up by 20 here. You don't necessarily need to do the same thing. You could potentially just set all of the velocity to push in one direction, like so, away from the monster's head here. And we're going to break this up with some noise in a moment, but I just get very picky about exactly how I shape these things. So for me, setting it based on this bit of vex seemed to work pretty well. And now that we have that velocity set, we can convert that to a volume with volume rasterize attributes and connect the set velocity to that. And for the voxel size, I'm going to set that to 0.06 since that's the approximate final resolution that I chose for my sim. And in the attributes parameter, I'm going to type both density and V. So now if you middle mouse that, you can see this is creating both density and velocity volumes. And at this point, it would be very helpful to visualize those velocities. So I'm going to pin the viewport in this subnet here and go back to where we set up that velocity trail. And I'll copy that and go back inside the subnet and paste it in here. And then I'll connect our volume to that. And then if you view that volume trail, you can see the velocities that I set up in my wrangle. And this looks like that's all pointing in the correct direction, but it's often nice to break this up with noise. Sometimes if you have lots of strong linear velocity all pointing exactly the same way, that can build up in the simulation into some kind of unnatural round mushroom shapes. And introducing noise just always tends to make things a bit more organic. Now to add that noisy breakup to those velocities, we can use the volume velocity SOP and drop that in after our volume rasterize attributes, and then go to the curl noise and turn on this add curl noise option. And with the strong velocities that we currently have, the scale of 1 isn't going to do very much, but if you turn that up, you can see tons of noise being added to those velocity directions. Now this is looking far too swirly and breaking up that directionality a bit too much, but if we turn that swirl size down, you can see that this is generally preserving the direction of our velocity while adding lots of noisy breakup to that. And this will help it to look a bit more natural in the simulation. Now if we go back to viewing our source here, I'm going to hide the velocity for the moment to check the density volume. So I'll add a visibility SOP, and in the group I'll type @name equals V, so that will just hide the velocity volume. And I'm going to use an attribute noise to break up these density values a bit. Now the best place to add that density noise is just before the volume rasterize attributes so that we modify the data on these points directly. And by default, this is adding a color attribute, so I'm just going to change that to density. And right now this is looking far too flat because we're just using the default Houdini headlight, but if you turn on our in-scene lights, then you can see all of the detail in that volume. So if we bypass the attribute noise, you can see it's a pretty subtle effect right now, but it is breaking up our density values a little bit. And this looks like this will be a pretty good starting point for this extra source. Now I only want this source to be added for 2 frames of the simulation. For this monster head impact, I decided I want those emission frames here to be 999 and 1000. So I'm going to add a null down here and a switch, and we're going to switch between the source and the null. So I'll connect the null first and our velocity and density volumes second. And then in the switch expression, I'm going to check to see if that frame number is equal to either 999 or 1000. And if that evaluates to true, then this will pass through the volume. Right now we're at 991, so it's just passing through the null. But as we step through here, once we hit those 2 frames that we want the emission to happen, then you'll see this volume pop up here. And since we're only sourcing this on 2 frames, it doesn't need to calculate that for the rest of the time range here, so I'm not bothering to cache this out. But if you wanted that small time savings on those couple frames, you could potentially cache this out if you'd like. But I think the difference there would be pretty marginal. Now the impact source for his hand is set up in a pretty similar way, but the creation of that source geometry was quite a bit different. So I started by time freezing the building at the frame where his hand impacts it. In this case, I chose frame 1002, and I blasted away everything aside from that one clump that his hand grabs. Then I've trimmed down that selection a little bit more because I didn't want the dust sourced on those couple of pieces on the top. And I've converted that to a VDB and dilated that out a bit. And I've also taken just the monster's hand just by blasting away everything except for this one area. And I've trailed that for a few frames. In this case, I've trailed this for 5 increments with a 0.5 frame increment every time. And I've time shifted that to the same frame as the damaged building here. And I've polyfilled this trailed version of the monster hand so that we can convert that to a VDB. Now that we have both the VDB for his hand and the dilated section of the building, I'm reshaping his hand a little bit to expand out that area, and I'm doing a VDB combine with the operation set to SDF intersection just to get that intersecting area. And I'm smoothing out that VDB a bit, and then I'm subtracting his hand from that smoothed out VDB so that we don't have that density inside his hand there. And then I'm finally converting that to polygons and animating that scale over the 2 frames of emission just to create a nice silhouette around his hand at both frames and to get some expansion in that source. And then finally adding a bit of mountain detail to that and subdividing it and adding some more detail. And finally converting that back to VDBs and subtracting his hand once again from that. And once we have this VDB source, the volume creation from that is essentially the same as it was for the head impact. A lot of these parameter settings are exactly the same as well. So the pyro source is going to create the same point density as that head impact using that particle separation of 0.03 and creating the density attribute. Setting the velocity is pretty similar, except I'm just using a reference point at the center of the bounding box to create these radial velocities based on the current point position and the vector to that center, and multiplying that up by 20. And once again, I'm noising up the density a little bit, and I've actually left all of these attribute noise settings at their defaults, aside from specifying density as the attribute to be modified. And then we rasterize the volumes based on those attributes and hide that velocity volume, and then finally noise up the velocity a bit. So if we view the velocity here, you can see it has those radial directions based on that central bounding box reference point. And just like we did with the head impact source, I'm using a switch to just pass through that volume on the 2 frames that I want to emit this source. So those volumes just show up for frames 1001 and 1002 based on this frame check and the select input of that switch. Now to export these sources from the subnet, I'm going to add some outputs. I'll connect one for that hand output here, and I'll create another one for the head. I've also added an extra source for his hand toward the end of the shot, because when he swings his hand down from the building, I wanted that to emit some more density and exert some more velocity on the sim. Now to set that up, I've started by just isolating this hand and lower arm, and I've trailed to compute some velocity on that. And then I've painted in just the areas that I want to emit from. Now I didn't want this density emission to come off the back of his hand. I wanted that to be more from the underside of his fingers and his palm there. So I just painted that area in, and I'm going to use the actual points of his mesh to create some trails for that source. So I've subdivided that a couple times to create a lot more resolution on that mesh. Now after adding that resolution, I'm using this wrangle here to set the density, and I'm ramping that density from 1 down to 0 over the course of 10 frames, from 1075 to 1084. And I'm also reducing that velocity a bit. And to only emit from those areas that I've painted in, I'm deleting all the points that have a color with a red component less than 0.5. And after just isolating that area and setting those attributes, I'm trailing his hand to create a few extra copies of that. And the trail length here is set to 5, but with an increment of 0.2, so it's only going back 1 frame, but with 5 substeps. And then I'm deleting all of the prims and just keeping the points and creating poly lines between those points. And I should also note that in order for those poly lines to work, it's doing that by an ID attribute, which I've also set at the beginning of this wrangle here. And now that we have those poly lines, I'm resampling those so that we have enough point resolution for our volume source, and I'm jittering that up a bit. And now that we have the points for that source, we actually don't need to use the pyro source this time to create the points, and I'm building the density and velocity volumes separately. So once again, I'm just doing a basic noise on that density, although in this case it's multiplicative instead of additive, and then I'm just rasterizing that density as we've done before. Although in this case, I tweaked the particle scale a bit to create a more focused volume. You can see the default particle scale here is pretty big, so in this case we had to turn that down in order to properly represent these shapes that we've built with these points. The reason we didn't have to do that before is because using that pyro source set up a p-scale attribute to control this for us. And after building that density volume, we're creating the velocity volume separately, and we have that monster's velocity on the source points here, so we can just rasterize that velocity attribute to a volume. In this case, we also have to turn down that particle scale a bit, and then once again, I'm using the volume velocity to break up those velocity directions a bit. And in this case, I'm actually animating the scale over time. So let's check out that volume trail here. You can see we have the monster's actual animation velocities being broken up with some noise. And as before, I only want this to be added for a certain frame range. So for the switch here, I'm checking if the frame is greater than or equal to 1075, and if it's less than or equal to 1090, in which case we will use those sources. And let's add an output for this source as well, and then add those to our simulation. And because we've added 3 outputs inside that subnet, you can see those reflected here, and I've added nulls for each of those that we can point our DOPNet sources to. And finally, back inside the DOPNet, we can set up volume sources for each of those. You could potentially merge them together in SOPs and then use one volume source for all of them, but I find it a bit more controllable to create different volume sources like this, because then we can art direct easily the amount of velocity contribution and density contribution from each of those sources without needing to change them in SOPs. And this is one of those things that you'll have to spend some time testing out in your sim and iterating on and tweaking. And it can be a bit time consuming to dial in just the right scale amounts for the density and velocity for each of them. And now when I'm merging those in, I'm going to disconnect my collide sources and the camera sources because I want those to be at the end. So I'll merge those in here and then reconnect those other sources. And then we can test this out and see what our sim looks like. And now checking out our new sim with these additions, you can see those emitted areas when his hand and his head hit the building. It looks like that head impact is looking pretty nice, at least in terms of it being visible enough and dense enough, and the amount of velocity contribution being reasonable, because we're getting that really nice silhouette right around his head there. It looks like we need to go heavier with the hand impact. Right now it's not very noticeable. We're definitely getting some extra emission around his hand, but I'd like that to be a lot more obvious. And the hand interaction at the end as well is pretty subtle. You can see his fingers dragging some of the dust around. Some of that might be just due to the normal collision behavior that we already had, although some of this is likely due to that extra density emission that we've added. And although that is pretty subtle, it is a nice touch. And just in terms of overall notes, we definitely need to tweak this sim some more. The whole thing is looking a bit too dense and too turbulent as well, but it is getting there. We're getting a lot of the nice richness of detail and behavior that we're looking for. We just need to tone this down a bit and increase the resolution of the sim. And right now the simulation really does look like overkill, but we're only a few tweaks away from a pretty nice dust layer.